Hello world, my name is Kshitij, this is the Coding Tree, and today we're talking about the Fibonacci sequence. Now, if you've been following my channel for a while, you'll probably notice that there's something a little bit different about today's format. And that's because I'm just trying something new, because today we aren't covering a new concept, but rather practicing an old one. A really complicated old one called recursion. Now, I'm sure you've seen my video from last month, but in case you haven't, go and check it out. It covers the entire basics of recursion and gives you some much needed context for today's video. Today, we're going to be talking about how to implement the Fibonacci sequence, a sequence of numbers that is used everywhere in mathematics, in programming. We're basically going to try to write a program that will tell you the nth Fibonacci sequence based on input. First, in case you missed the recursion video, let me just give you a brief overview. All recursion is calling a function within itself. So, today, we're going to be implementing that concept to program a Fibonacci sequence. Now, I know some of you might be wondering, what exactly is a Fibonacci sequence and why should I care about it? Well, Fibonacci sequence in and of itself is nothing special. All it is adding each number with its subsequent number in the pattern. So my first number would be 1, and then the number, we assume that the number before that is 0. So you add 0 to 1, what do you get? You get 1. And then you add 1 and 1. And what do you get when you add 1 and 1? You get 2. And you add 2 and 1. Which will give you 3, 2 and 3, 5, 3 and 5, 8, 5 and 8, 13, and so on. So that's essentially what the Fibonacci sequence is. It's just adding the current number with its subsequent number and getting the result and continuing the pattern. But why should you care about the Fibonacci sequence? Well, something really interesting about the Fibonacci sequence is that the numbers that are in the pattern are, for whatever reason, quite commonly observed in nature. Now, I'm going off on a little bit of a tangent here, but something really interesting about the Fibonacci sequence is that the numbers that are in the Fibonacci pattern, the Fibonacci numbers, are quite often observed to occur naturally in nature, more so than other numbers. Think about the number of petals a flower has. It is more likely that it's one of the Fibonacci numbers than not, for some reason. Nobody knows why, but that's just something really interesting that humans have observed about the Fibonacci sequence. Alright, now let's get to why we're all here. So the Fibonacci sequence is really cool, but we also need to understand how to implement it with programming. And I'm sure you can totally implement this using iterative loops. However, we're here to practice recursion, so that's what we're going to do. Now, take a quick minute and try to figure out how exactly the Fibonacci sequence would work as a recursive function. I'm going to give you a minute to think about this, so just pause the video, try to figure it out. You don't necessarily have to code anything, just conceptualize it. We'll come back, we'll talk about it in further detail, and then I'll code it right in front of you. So in order to program a program which finds the nth term of the Fibonacci sequence, you actually have to do so by going kind of backwards. Essentially, you have to do so by finding the, if you're trying to find the nth term, you have to find the n-1 term. So on and so forth until you get to the first or the second term, which you know is going to be 1 and 2. So, what does that exactly imply? Well, that means that 1 and 2 become your base cases. Remember what a base case is? If you don't, make sure to go back to my recursion video, because I cover all of that in that video. But essentially, that's where we're going to stop our recursive call, is when we get to finding the first and the second term. So essentially what we have to do, since the nth term is just an addition of all of the previous terms in a way, we have to find the n-1 term until we get to the first and second term, in which case we just return 1 and 2. let's get to programming this. So first, obviously, we just have to define a function using the function keyword in Python and pass in a parameter. I'm going to pass in the parameter of n, which is going to represent the nth term that our user wants to find. Next, we have to check if n is equal to 1 or it's equal to 2. That's pretty simple. It's just a simple if condition. If n is equal to 1 or n is equal to 2, then we run our base case. We're getting our base case out of the way right now, so we don't have to worry about it later. So if this is the case, then we just simply return n. And so if n is 1, we return 1. If n is 2, we return 2. That's our base case done. That's when our program knows to stop doing whatever it is doing. Next, we actually have to do a recursive call. And that's going to happen in an else statement when n is not equal to 1 or 2. And it's going to happen when we're going to return the same function, but n minus 1 to get the n minus 1 sequence, plus Fibonacci n minus 2. So essentially, what this does is that when we do this, we're getting the last term, because each Fibonacci sequence is just n minus 1 plus n minus 2. So the current Fibonacci number is equal to the Fibonacci sequence n minus 1, the n minus 1th Fibonacci sequence plus the n minus 2th Fibonacci sequence. Now I know that sounds a little complicated, so let me draw it out. So let's see what exactly happens when we call Fibonacci, our Fibonacci function, with a call of 4. So we're simply trying to find the 4th function. How can we possibly do this with what we just wrote, just our measly 4 lines? Well, it's actually pretty simple. So when we initially call 4, we split that off into 2 recursive calls, since the base case does not run for 4. Since 4 is not equal to 1 or 2. Because of this, we have 2 different branches that we go on to, 3 and 2. 2. Well, that's our base case. If we go back here, if n is equal to 2, we return n. That's our base case done. So in that case, we don't have to worry about this. We simply return 2 here. And since for 4, we return 2 plus something else, the 4th term, we return 2 plus something else. 3 here is also split off, because this return runs the recursive call here, which is Fibonacci 3 minus 1, so Fibonacci 2 and Fibonacci 1. Well, when we do this, Fibonacci 2 is just again, it's a base case, so we return 2, and this is also a base case, so we return 1. So what does our Fibonacci sequence end up becoming? Well, somehow it's 1 plus 2, which is 3, and then 3 plus 2, which is 4. Do you notice a pattern here? We go from the first number of the Fibonacci sequence to the second by adding 1 and 2, and then we add 1 and 2, which it gives us 3, our third number, because it's 1 plus 2, and then we add 2 over here in this part of the branch, and 2 plus 3 is 5, which is the 4th term, which is what this call returns. That's the same thing as this call right here. So essentially, by going from the top all the way down, we get our intended result, and we compute everything and get our final result. In fact, if I go over here and run outside of the function, hopefully, and run the Fibonacci code, I could type Fibonacci of 4, and then I run that, it gives me the 4th term, which is 5. That works perfectly. If you got that solution, great job. That's really hard to do as a beginner, so props to you. However, there is still a problem with the solution. And that's the fact that we are simply computing too many values. Sure, 4 works. Let's check if 30, trying to find the 30th term, if that works. That, as you can see, there's a little bit of delay there. Now let's try to find the 100th Fibonacci term. not producing a result yet. It's going to take a while. Why is that? Well, even though I have a pretty beefy computer, it's going to take a while simply because of how much we're trying to do. We're trying to do way too much, and simply because of that, we're computing too many values. Why does this happen? Why is our code that we just wrote so inefficient? Well, that's because of what we're actually doing here. Because we're kind of branching down so many times, if it's a large number, we're branching down so many times. For 100, we're branching down to 99 and 98, 98, 97 for the left side, and then keeps going for each individual path twice. That's a lot of computation to do. Unfortunately, that's something that our code is not very good at, being efficient. However, there's actually a pattern here that you can see. If even in this case, there's actually a pattern here. If you go to 100 and we branch off into 99 and 98, and then we branch off to 98 and 97, do you notice something? Here we have 98 and we have 98 again here. What's going to happen here? Well, when we compute 98 on this side, we're also going to compute it on the left side. We're going to compute it twice. Why do that when we can just store our information in a variable? Or rather, in a list of sorts. I'm going to try to let you figure out on how to make this code efficient. Your clue is you're going to need to use a dictionary. You're going to need to store that information and use it to check if we have already computed a value and we need to compute it again. If we do need to compute it again, you can compute it. Otherwise, just use the value that you've already computed and stored. Thus, we're going to simplify the amount of computations our computer has to do, and hopefully, we'll be able to run this code. So, go ahead and try to do that. Pause the video. We'll get back together once you try to figure it out. Don't worry if you don't get it. And I'll totally explain everything in a little bit. So, like I said, you're going to have to use a dictionary. So how we're going to do this is simply check first if n, which is going to be a key, we're going to store every value as a key and every actual Fibonacci number as a value. If n is in is a keyword in Python, it simply checks if a dictionary contains a number as a key. So if n is in D, all I'm going to do is return the value associated with n as a key. That sounds a little bit complicated. Go brush up on my dictionaries video. It's going to be linked in the description in case you need to revisit this concept. Next, I'm going to do something, and I'm going to store our old return statement. Return fib n-1 plus fib n-2 in a variable. And I'm going to add my second parameter this time because we are changing our header of our function. And I'm going to return, instead of returning that, I'm going to store it in a variable, and then I'm going to add it to my dictionary. I'm going to do D, the key of n. The key is, like, let's say it's the fifth. It'll store the fifth term as it'll store 5 as a key and the fifth term in the Fibonacci sequence as a value. D of n is equal to temp, and then I'm going to return temp. That's it. That's the entire function, and now our code is so much more efficient. So here, if I run this code, first I have to actually create my dictionary, and I'm going to do that by storing our old base cases 1 1 and 2 2 in the dictionary. Now this may look a little bit complicated, but what I'm actually doing here is essentially expanding our base cases. I'm making it so our computer stops running and doesn't run a recursive call more often, since we've already computed those values. We don't have to compute them twice. So now if I run this code, if I print Fibonacci, if I could type 4, let's say, just use the same example as before again, and then D as my dictionary, which is essentially my list of base cases, which I'm going to continuously expand. Boom, that prints 5. That works phenomenally. However, let me try printing 100 this time, something that didn't work before. Boom, an extremely large number, but it prints almost instantly. And that's the beauty of dictionaries, because we can do so much. We can even do 200, and it goes off your screen, off my screen, but it works. It prints the entire number. And that's because we're simply writing more efficient code. That's a really important lesson to learn early on, that writing code that works isn't exactly our goal. Writing code that is efficient and works is our goal. Hopefully, you learned something with this video. That's all for now, folks. I hope you enjoyed, and I hope you learned something. If you did, make sure to leave a like, and if you want to continue your computer science journey, make sure to subscribe. Now, I know this was a bit of a weirder video, not really focused on learning, but rather practice. And that's something I kind of want to do more often, because I feel like practicing in computer science is just as important as learning programming concepts. So, if you enjoyed this type of format, make sure to let me know in the comments. And yeah, that's all for now. Have a spectacular day.